Welcome back, Chemistry 30. So if we look at, again, at a close-up of this connecting point here, the salt bridge, consists of a U-shaped tube containing an electrolyte solution, such as sodium chloride, or it could be various other ionic compounds that have positive and negative ions, whose ions will not react with other ions in the voltaic cell or with the electrodes. That's a key point. The electrolyte is often incorporated into a paste or gel so that the electrolyte solution does not pour out of the U-tube when it's inverted. As oxidation reduction proceeds at the electrode, ions from the salt bridge migrate into the two half cells where they're needed. So the cations, which of course are the positive ions, migrate to the cathode, because remember that's where the copper ions are becoming reduced, so to replace what's being lost. And anions migrate to the anode half cell to neutralize the charge in that. So that's, of course, where the zinc is breaking down into zinc ions. Zinc positive ions can become neutralized by the ions from that salt bridge. Whichever device is used to allow ions to migrate between two half cells, anions migrate towards the anode and cations towards the cathode. So kind of their name migrates to what they need. Anions to anode, cations to cathode. Each zinc atom in the surface of the anode loses 2 electrons. It becomes the Zn2+ ion in the anode department. We envision the 2 electrons traveling from the anode through the wire to the cathode. So again, over here, so when the solid zinc becomes Zn2+, it loses 2 electrons, so the electrons are going to move out this way. So it's like the zinc anode has a surplus. It's like the negative pole of the battery. So we envision them doing that. At the surface of the cathode, a Cu2+ ion from the solution gains 2 electrons to form the copper atom. So over here, these electrons travel to here, and they're quickly lost from the copper 2+, taking in those 2 electrons to become copper atoms. So it's almost like this is the positive pole of a battery. So the zinc anode gets consumed, the copper at the cathode gets positive. The redox reaction between zinc and copper 2+ is spontaneous regardless of whether they are in direct contact, like at the start of this section, or when they're separated but they're connected by a salt bridge and an external wire, as in the electrochemical cell or voltaic cell. In each case, the overall reaction is the same, only the path by which the electrons are transferred is different. The figure below right summarizes the various relationships in a voltaic cell or electrochemical cell. Notice that the electrons flow from the anode through the external circuit to the cathode. Because of this directional flow, the anode in the voltaic cell is labeled with the negative sign, because that's where the electrons are being removed from. And the cathode is labeled as a positive, because they're going to here where they quickly get taken up by the positive ion in solution and deposit on there. So we can envision electrons as being attracted to the positive cathode from the negative anode. So this kind of summarizes everything that's going on. So we have the anode where the solid atom is losing 2 electrons to become an ion in solution. And of course it needs to attract the negative anions to become neutralized. And then they leave, the electrons leave, they come over here, and over on this side, the cations that were in solution take, whether it's copper, takes in the electrons, deposits here, so we have to replace the cations that were taken away. Okay, so that's kind of how that all comes together. So let's bring this all together and see if we can do an example in which we have a redox reaction and it's forming an electrochemical cell. We'll label things to show how that all comes together. All right, so over here, the oxidation reduction reaction, so we have this. It's completely balanced already. It's spontaneous. A solution containing K2Cr2O7 and H2SO4 is poured into one beaker, and a solution of Ki is poured into another. A salt bridge is used to join the 2 beakers. A metallic conductor that will not react with either solution, so we're using that for anodes and cathodes so they don't get used up, is suspended in each solution. And the two conductors are connected with wires through a voltmeter or some other device to detect an electric current. The resultant electrochemical cell generates an electric current. Describe the reaction occurring at the anode, the reaction at the cathode, the direction of the electron migration, and direction of ion migration, and the signs of electrons. So where the electrons are going and where ions are going as well. Now, if we look up here, we can kind of predict what's going to happen here. So H's, of course, remain the same. But what we could do is just kind of run through this. So oxygen is -2. 2 times 7 is -14. Since it has an overall charge of -2, we know this needs to result in -2, which means this must be +12. Since there are 2 chromium atoms involved there, it's +6. Look over here, chromium is 3+ ion, so we have +3. So over here we know that the chromium is getting reduced because it's going from a +6 to a +3. So we know that's where the reduction is going. And hydrogen we can assume is not undergoing anything, so let's look over here. We have a -1 here. I'm not even worrying about the balanced equation yet. Just look at what's happening to each individual one. And then over here to 0. So -1 going to 0, we know that is oxidation. Okay, so there we know what substances are being reduced and what's being oxidized. So we can go from there. So let's look at, so we have the 2 separate pieces here. So let's look at the oxidation part. We'll look at it over here. Just pulling the ions that are being oxidized. So I- is going to I2. And over on this side, we could look at Cr2O7 becoming Cr3+. And again, we used what we did in the previous section to see, well, how does this all work? How do we balance this? How did it become this big equation here? By looking at these 2 half reactions. So we're just going to do the same thing that we did, those steps. So first of all, we have to balance non-zeros and non-H's. So we have that. And so we have 2 and resulting in 2. And now we look at, so there's no oxygen to balance, there's no hydrogen balance. So now we just have to balance charges, right? So over here we have a -1 charge here. Let's do it like this. There's one negative, but we have 2 of them. So that's going to give us a total of 2 negatives. Over here we have 0, so that's a total of 0. So to balance this charge, these charges, we need to add electrons to one of these sides. So of course you add electrons to the more positive side. So this is the more positive side. If we add 2 electrons there, we will get what we need. So overall the reaction is 2I- going to I2 plus 2 electrons. So just like what we did in the previous section. Okay, so that's where the oxidation, the I- ions are releasing 2 electrons to become iodine. Over here, so first of all, balance non-hydrogens and non-oxygens. So we need to do this. We have 2 chromiums there, so we need 2 chromiums on this side. Okay. And then we have to, well, we're oxygen deficient on the right. Okay, and we know this is going to be in an acid because we have H+ ions floating around. So we need 7 oxygens. So we get that by adding 7 water molecules. And of course, in that process, I'm going to be adding 14 hydrogens. So 14 hydrogens are added. Now that is completely balanced. So now we look at charges. Here we have +1 charges. We have 14 of them. And here we have a 2 negative charge, and we only have 1 ion that has that. So that's going to give us a grand total of 14 positives, 2 negatives. So that's 12 positives. Over on this side, we have a 3 positive, and we have 2 of them. And over here, we have neutral, 7 of them. So 2 times 3 is 6 positives. So to make this neutral, of course, the more positive side is over here. So we need to add electrons there to balance this out. So if I add 6 electrons, I'll have that exactly how I need it. So 12 minus 6 is 6 positive. So the reaction here will be 14H plus Cr2O7 plus 6 electrons gives me 2 chromium 3 plus ions and 7 H2Os. Okay, so if we take a look at what happened here, we have 6 electrons, 2 electrons. So what I can do over here to make this equal is to multiply everything by 3 over here. So 2 times 3 is 6. 1 times 3 is 3. 2 times 3 is 6. So then I have everything that I need. Now, if you notice, if I was to combine these equations like I did in the previous section, on the left-hand side, I'd have 14H pluses, Cr2O7. So look at that. So I have 14 pluses, 14H pluses. Look at that. Cr2O7, 2 negative. There it is. Plus 6 iodides. 6 iodides. Then on the right, 3 I2s, yes, and 2 Cr3 pluses, and then 7 H2O. 7 H2O. So it all comes together perfect. What we'll do is we'll stop the video there, and we'll draw a little picture of what's happening here with these two reactions.